Service equipment for floating structures and submersible electrical equipment must be no closer than 20 feet horizontally from the shoreline. This requirement is in place to ensure safety and prevent electrical hazards associated with water in proximity to the shore. Several factors contribute to the need for this minimum distance. Firstly, the presence of water significantly increases the risk of electric shock. Water is an excellent conductor of electricity, and any electrical fault near the shoreline could easily energize the surrounding water, posing a serious threat to anyone in or near it. Secondly, floating structures are subject to movement due to waves, tides, and currents. This movement can place stress on electrical connections and equipment, increasing the likelihood of damage and potential electrical hazards. Maintaining a safe distance from the shoreline helps to minimize the impact of this movement in the electrical system. Thirdly, submersible electrical equipment is designed to operate underwater, but it is still vulnerable to damage and corrosion. The presence of salt water, in particular, can accelerate the deterioration of electrical components, leading to malfunctions and potential electrical hazards. Keeping submersible equipment at a sufficient distance from the shoreline reduces its exposure to saltwater and other corrosive elements. The 20-foot minimum distance is specified in the National Electrical Code, or NEC, which is a widely adopted standard for safe electrical installations. The NEC provides detailed requirements for electrical systems in various locations, including those near water. Compliance with the NEC is essential to ensure the safety of people and property. The specific section of the NEC that addresses service equipment near shorelines provides guidelines in the installation of electrical equipment for floating buildings, structures, and other equipment intended for use in or near water. The code emphasizes the need for weatherproof enclosures, proper grounding, and overcurrent protection to minimize the risk of electrical hazards. When installing service equipment near a shoreline, several key considerations must be taken into account. 1. The location of the equipment should be carefully selected to minimize exposure to water, waves, and other environmental factors. 2. All electrical connections must be made using waterproof connectors and fittings to prevent water from entering the system. 3. The equipment must be properly grounded to provide a path for fault current to flow back to the source, reducing the risk of electric shock. 4. Overcurrent protection devices, such as circuit breakers and fuses, must be installed to protect the equipment and wiring from overload and short circuits. 5. Regular inspections and maintenance should be performed to identify and correct any potential problems before they become hazards. In addition to the NEC requirements, local regulations and ordinances may also apply to electrical installations near shorelines. It is important to consult with local authorities to ensure compliance with all applicable codes and standards. Furthermore, the type of floating structure or submersible equipment will influence the specific electrical requirements. For example, a large marina with numerous boats will have different electrical needs than a small dock with a single boat lift. Similarly, the type of submersible equipment, such as a pump or a lighting fixture, will determine the appropriate wiring and protection methods. The environment surrounding the shoreline can also impact the electrical system. For instance, areas with high humidity, saltwater spray, or frequent flooding will require more robust protection measures. The use of corrosion-resistant materials such as stainless steel or fiberglass is recommended in these environments. Another important consideration is the potential for lightning strikes. Lightning can cause severe damage to electrical equipment and pose a significant threat to safety. Lightning protection systems should be installed to protect structures and equipment from lightning strikes. These systems typically include lightning rods, grounding conductors, and surge protection devices. The design and installation of lightning protection systems should be performed by qualified professionals in accordance with industry standards. Proper grounding is critical for electrical safety near shorelines. Grounding provides a low impedance path for fault current to flow back to the source, minimizing the voltage on exposed metal parts and reducing the risk of electric shock. The grounding system should be designed to effectively dissipate fault current and prevent the buildup of dangerous voltages. The grounding electrode system should consist of one or more grounding electrodes, such as ground rods, ground plates, or underground metal water pipes. The grounding electrode should be installed in accordance with the NEC requirements and should be properly bonded together to create a low impedance grounding path. In addition to grounding, bonding is also important for electrical safety. Bonding involves connecting all metal parts of the electrical system together to create an electrically continuous path. This helps to equalize the voltage on all metal parts and reduces the risk of electric shock. Bonding conductors should be sized in accordance with the NEC requirements and should be securely connected to all metal parts of the electrical system. The use of ground fault circuit interrupters, or GFCIs, is also highly recommended for electrical circuits near shorelines. GFCIs are devices that detect small imbalances in current flow and quickly interrupt the circuit, preventing electric shock. GFCIs should be installed in all receptacles and circuits that are likely to be used near water. GFCIs are particularly important for protecting people from electric shock when using portable electrical equipment, such as power tools and appliances, near the shoreline. Regular testing of GFCIs is essential to ensure that they are functioning properly. The NEC requires that GFCIs be tested monthly by pressing the test button on the device. If the GFCIs do not trip when the test button is pressed, they should be replaced immediately. When selecting electrical equipment for use near shorelines, it is important to choose equipment that is specifically designed for wet or damp locations. This equipment is typically constructed with corrosion-resistant materials and is designed to prevent water from entering the enclosure. The equipment should be labeled as suitable for use in wet or damp locations. The type of wiring used for electrical circuits near shorelines is also important. The wiring should be rated for wet locations and should be installed in a manner that prevents water from entering the conduit or raceway. The use of underground wiring is often preferred for electrical circuits near shorelines as it provides greater protection from the elements. The underground wiring should be buried at a sufficient depth to prevent damage from digging or other activities. The wiring should also be protected from physical damage by using conduit or other protective measures. The installation of electrical equipment near shoreline should be performed by qualified and licensed electricians. These electricians have the knowledge and experience to ensure that the electrical system is installed safely and in accordance with all applicable codes and standards. They can also provide guidance on the selection of appropriate equipment and wiring methods. Regular inspections of electrical systems near shorelines are essential to identify and correct any potential problems before they become hazards. These inspections should be performed by qualified electricians and should include a thorough examination of all electrical equipment, wiring, and grounding systems. The inspection should also include testing of GFCIs and other safety devices. Any identified problems should be promptly corrected to ensure the safety of people and property. The 20-foot minimum distance requirement is not arbitrary, but rather a carefully considered safety measure based on years of experience and research. It takes into account the various factors that can contribute to electrical hazards near shorelines, such as the presence of water, the movement of floating structures, and the corrosive effects of salt water. By adhering to this requirement, the risk of electric shock and other electrical hazards can be significantly reduced. In summary, maintaining a safe distance of at least 20 feet between service equipment and the shoreline is a crucial safety measure for floating structures and submersible electrical equipment. This requirement, as specified in the NEC, helps to minimize the risk of electric shock and other electrical hazards associated with water in proximity to the shore. By following the NEC guidelines and implementing appropriate safety measures, the electrical system can be installed and maintained in a safe and reliable manner.